Assalamualaikum dan selamat sejahtera semua. So, dalam video ni kita akan discuss exercise 2 dalam learning outcome 4.2a, apply Newton's law of motion. Okey, untuk apply Newton's law of motion, so kita akan apply sama ada net force x equals to 0 dan net force y equals to 0. Okay, keadaan ni berlaku bila objek at rest ataupun objek moving tapi dia moving dengan constant velocity. Okay. And then satu lagi kemungkinan kamu akan apply net force x equals to ma dan net force y equals to 0. Keadaan ni berlaku bila objek move with acceleration A, they accelerate. Okay, they accelerate at x component. Okay, dia hanya accelerate pada x component. Okay, tapi pada y component dia bergerak dengan constant speed ataupun dia tak bergerak langsung, dia in equilibrium. Okay, jadi dia hanya ada acceleration pada komponen x. Okay, satu keadaan lagi mungkin dia accelerate pada komponen y. Jadi komponen x dia in equilibrium. So net force y equals to ma. Okay, untuk yang ni objek accelerate at y component. Okay, accelerate at y component. Okay, so let us start. As to question number 1. A load of 250 kg is hung by a crane cable. The load is pulled by a horizontal force such that the cable makes a 30-degree angle to the vertical plane. If the load is in equilibrium, calculate the magnitude in the tension T and the horizontal force F. Okay, state that the load is in equilibrium. So when it is in equilibrium, so we must apply net force x equals 0 and net force y equals to 0. Okay, but then we have to identify what kind of forces acted on this load. Okay, so you have to draw all forces acting on this load. Okay, so this load have weight, of course, okay, downward, and then it has tension because this is the cable here. Okay, along the cable have tension, and then this is the horizontal force F. Okay. So we have weight at y component and F at x component, and then T is tilted. So we can resolve T into x component and y component. Okay, so this is the x component of tension T, and then this is the y component for the tension Ty, and then we can apply net force x equals to 0. Okay, summation force at x component equals to 0. So we have F and Tx at x component. So F plus negative Tx. Negative Tx because Tx direction is to the left. Okay, equals to 0. So Tx is T sine 30 degree. Okay, we can relate Tx with T and the angle theta. Okay, so this equation have two unknowns, F and T. Okay, we leave that equation. Okay, Okay, proceed to net force y equals to 0. Net force y equals to 0, so we have Ty and W. Okay, Ty and W. Okay, we have Ty and W. Okay, at this area, Ty and W. Ty upward and plus negative W. W is downward, so it is negative. Okay, simplify. Ty is T cos theta, T cos 30 degree, because okay, we relate Ty with T and angle theta. Minus weight equals to mg equals to 0. So now we have two equations with two unknown. Alright, the rest is mathematics. Okay, so maybe we can divide these two equations. Okay, for our equation 1, maybe we can let T sin theta, T sin 30 degree be the subject. Okay, so this is the equation 1. And then this one is equation 2. Okay, so we can divide equation 1 with equation 2. Equation 1 divide with equation 2. So left hand side equation 1 divide with left hand side equation 2. Alright. And then right hand side equation 1 divide with right hand side equation 2. Okay, now we can simplify. Okay, we can cancel the T. Sin 30 degree divide with cos 30 degree equals to tangent 30 degree. Okay, so tangent 30 degree equals to F over mg, where m is 250 kilogram. Okay, mass, m is the mass must be in unit kilogram. Okay, and then g is 9.81. Now we can have value of f. Okay, so it is tangent 30 degree times 250 times 9.81. So it is equals to 1415.95 Newton. Alright, and then how about F? So we can get value of F. F already we have already got. Okay, it is 1415.95 Newton. How about T? So maybe we can use equation 1. Okay, so from equation 1, T sin 30 degree equals to F. Okay, where F is 1415.95. So T is equals to 1415.95 divide with sin 30 degree. So it is equals to 283.90 Newton. Okay. Okay, the answer here is 2833 and 1417 Newton for both tension and horizontal. This is only the guideline. Okay, it's okay. Number 2, calculate the magnitude and direction of a force that balance the three forces acted at point A. Okay, magnitude and direction of a force that balance the three forces acted at point A. So we already have F1, F2 and F3. So we need another force to balance these three forces. Okay, so maybe we can call it F4. Okay, so we want to find the magnitude of the F4 and the direction of the F4. Okay. Okay, the key word here is balance. Okay, balance. The concept is net force X equals to 0 and net force Y equals to 0. Okay. So we can add all F1, F2 and F3, but then they are not parallel. So we have to resolve F1, F2 and F3 into X component and Y component. So for F1, this is X component for F1, and then this is Y component for F1. And then for F2, this is X component for F2 and this is Y component for F2. And then for F3, this is the F component for F3 and this is Y component for F3. Alright, then we can add F1x plus F2x plus F3x, and then the force is F4x. Okay, we don't know what's the location of the F4. Okay, to balance these three forces. Okay, so F1x is F1 cos theta. So it is 12 cos 55 degree. And F2x is to the left, so it is negative. Okay, negative F2 cos. Okay. We can simply substitute the value of F2. F2 is 20 cos 30 degree, and then plus negative F3x, negative because it is to the left, so F3 is 30 cos F3x is negative 30 cos for 45 degree. Okay, and then plus F4x, which is the unknown. Okay, so we can calculate the F4x. So it is 12 cos 55 minus 20 cos 30 degree minus 30 cos 45. So it is equals to negative 31.65. So F4x be the subject, so it is equals to 31.65. Okay, 31.65 Newton. And then how about component Y? Net force Y equals to 0 because it is balanced, so it is in equilibrium. So we have F1Y plus F2Y plus F3Y plus F4Y. So they are equals to 0. F1y is upward, so it is positive 12 sine 55 degree. F2y is also upward, so it is positive. It is 20 sine 30 degree. And F3y is negative because it is downward, so it is 30 sine 45 degree. And then plus the force is F4y, so it is equals to 0. Then we can calculate value of F4y. It is 12 sine 55, okay, plus 20 sine 30 degree, okay, minus 30 sine 45. So let F4y be the subject, so it is 1.38 Newton. Okay, then we can determine the magnitude of F4 by using formula F4 equals to F4x squared plus F4y squared. Substitute, okay, F4x and F4y. Okay. Okay, plus 31.65 squared square root answer. So it is equals to 31.68. 31.68 Newton, and the direction is from theta equals to inverse tangent F4y over F4x. Okay, 1.38 over 31.65. So this equals to 2.496. Okay, so we can round off to 2.5 degree. Okay, 2.5 degree. So where is the location? Maybe we can sketch like this. Okay, this is the x-axis and this is the y-axis. Alright, so the x-axis is positive, so it is at this area, and the y-axis is positive as well, so it is at this area. So the F4 is at first quadrant. Okay, this is the F4. So therefore the reference line is always the x-axis. Okay, so the theta here is 2.5 degree above positive x-axis. Okay. Question number 3. A window washer pushes his scrub brush up a vertical window at constant speed. Okay, so the keyword here is constant speed. That means we have to apply net force X equals to 0 and net force Y equals 0. Okay, by applying a force F as shown in figure, the brush weight 10 Newton and the coefficient of kinetic friction is 0.125. Okay, so this is the coefficient of friction, not the friction yet. Okay, it is still coefficient of friction. We can determine friction by using formula friction equals to coefficient of friction mu times normal force N. Okay. Calculate the magnitude of force F and the normal force N. Okay. Normal force N exerted by the window. Okay, so for this case, we can apply net force X equals to 0 and net force Y equals to 0. Okay, but first we have to draw all the forces acting on this brush. Okay, so this is the brush. Okay, and then this brush have weight, of course, downward, vertically downward, and then it has force F here, and then it is in contact with the window, so it has normal force perpendicular to the window surface and 90 degree. And then okay, say that in the coefficient of friction is given, that means this window have friction. Okay, so what is the direction of the friction? Okay, so when we want to identify the direction of the friction, we have to find out the tendency of this object to move upward or downward. So this scrub brush, okay, this brush tends to move up the window because it has force F. Okay, if the force F is okay, if the force F is large enough to overcome the weight, okay, so the brush will move up the window. If the force is not large enough to overcome the weight, so the brush will go down the window. So the friction will be up the window. So for this case, we can make an assumption that the force F is big enough to move up the window. So the frictional force is down the window. Okay? It is along the window, along the surface. Okay, friction will be along the surface and away from the direction of motion. Okay, so we have friction and W at y-axis and normal at x-axis, and F is tilted, so we have to resolve F into x component and y component. Okay, Fy. Okay, so look at this area. Okay, this is the x component. Okay, we have N and Fx. Okay, so for net force X equals to 0, summation Fx equals to 0. So we have Fx plus negative N, because negative N is direction N is to the left. Okay, so Fx we can relate with the angle here. Okay, it is equivalent with this angle 50 degree. Okay, so Fx will be F cos 50 degree. Okay, N is unknown. Okay, so we have two unknown in this equation, F and N. And then proceed to y component. Net force Y equals to 0. So for y component, we have okay, look at this area. We have Fy, friction F, and W. So for summation force at y component is Fy plus negative friction plus negative w equals to 0. So simplify Fy. Fy is f sine 50 degree minus friction. Friction equals to mu times normal, and w is mass times acceleration due to gravity. Alright, so we have two equations now with two unknown, which is n and f, right? Okay, the rest is mathematics. Okay, maybe from equation 1 we can let n be the subject, so n equals to f cos 50 degree. Okay, substitute equation 1 into equation 2. So we have f sine 50 degree minus mu. Mu is 0.125 here. 0.125, and then n from equation 1, it is f cos 50 degree minus mg, but then it is already given the weight is 10 Newton, so we can simply substitute mg as 10. Okay, this is the weight of the brush. Okay, so they are equals to 0. Okay, now we can get the value of f. Okay, this sine 50 degree is 0.766 f minus cos 50 degree times 0.125 equals to 0.08. Okay, f minus 10 equals to 0. So f equals 14.58. Okay, 14.58 Newton. And then for the value of n, we can determine from equation 1. So n equals to f cos 50 degree from equation 1. Okay, 14.85 cos 50 degree, so n equals 9.37. Okay, 9.37 Newton. Okay. We have T1 away from object 40 Newton and T2 away from object 40 Newton. Okay, so maybe we can draw free body diagram here. So it has weight of 40 Newton and then T2, okay, and T1. Okay, T1 is tilted, so we can resolve T1. Okay, we can resolve T1 to T1x and T1y here. Okay, and then how about object 50 Newton? Okay, so for object 50 Newton, it has weight. Okay, weight, maybe we can name it as weight B, and then weight B for 50 Newton, and weight A for object 40 Newton. Okay, alright, and then it has tension T3 away from object 50 Newton, and it also has T2 but away from object 50 Newton. So for object 50 Newton or object B, okay, object B, and the object 40 Newton is object A. Okay, maybe you can name it as 1 and 2. Okay, doesn't matter. Okay, so we can draw the free body diagram for object 50 Newton. Okay, so it has weight vertically downward, and then it has T3 here, and it has T2 horizontal. Okay, so T3 is this is T2. Okay, T3 is tilted, so we have to resolve into x component. Okay, T3x, and into y component T3y. Okay, so we want to apply Newton's law. So it state that the system in equilibrium, so that's mean net force x equals to 0 and net force y equals to 0 for both objects. Okay, this is weight A. Okay, so for object A, okay, for object A, net force x equals to 0. So we have this force, okay, at x component. So it will be T2 plus negative T1x equals to 0. So T2 is unknown and T1 is unknown too, but we can simplify. So T1 is, okay, from this diagram, the angle 35 degree is here. Okay, 35 degree is here. Okay, so you can use angle 35 degree, or you can use this angle. Okay, this angle will be 90 minus 35. So it is 55 degree. So if you use 55 degree, so T1x will be T1 cos 55 degree. Okay, equals to 0. Or if you want to use 35 degree, it will be T1 sine 35 degree. The values are the same. Alright? Okay. And then for component Y for 40 Newton, okay, net force Y equals to 0. So you have T1 Y upward plus negative weight object A of 40 Newton downward, okay, equals to 0. So T1Y is T1 sine 55 degree minus weight 40 Newton, it is 40. So it is equals to 0. Then you can simply get the value of T1 from this formula. Okay, it is 40 divided with sine 55 degree. So it is equals to 48.83. Okay, T1 equals to 48.83 Newton. Okay, and then you can also determine T2. Okay, so T2 from here, T2 equals to T1 cos 55 degree, where T1 is 48.83. So this equals to 28 Newton. Okay, 28 Newton. And then how about the object B, or the 50 Newton object? Okay, the 50 Newton object concept is also net force X equals to 0. So look at this area. Okay, so you have T2 and T3X. Alright, so can be the T3X plus negative T2 gives to 0. Alright, so T3X. Okay, the angle theta is here. Okay, angle theta is here. Okay, that's mean we have to use that angle. Alright, okay, so T3X will be T3 sine theta. Okay, or maybe you can calculate T3X first. So it will be like this. So T3X equals to T2. Okay, so T3X is 28 Newton. And then how about T3Y? Okay, T3Y is in this area. Okay, at Y component. So net force Y equals to 0. So T3Y plus negative weight B equals to 0. So T3Y minus weight B is 50 Newton. So T3Y equals to 50 Newton. Okay, then T3 is equals to T3X squared plus T3Y squared. Okay, so we can determine T3. Okay, T3X 28 squared plus 50 squared, square root answer. So it is equals to 57.31. Okay, 57.31 Newton. Okay, So we can determine direction. Theta equals to inverse tangent T3y over T3x. But theta that we calculate here is at this area. Okay, let me show you. Because the reference line is always the x-axis. Okay, never mind. We can calculate that mark theta in that question. Okay, so 50 over 28, and then inverse tangent answer, so it is 60.75 degree. Okay, so theta in that diagram will be 90 minus 60.75 degree. So it is equals to 29.25 degree. Okay. Alright. Or you also can solve like this. Okay, at this area. Okay. You can solve like this. T3x is the T3x is the from here. T3x is the T3 sin theta equals to T2. Okay. Theta is unknown. T3 is also unknown. Well, T2 will have already calculated. It is 28. Then, okay, 28 Newton. And then for this area, okay, you also can solve like this. T3y is 3 cos theta. Theta is unknown. Okay, that means theta theta here is theta that marked in the question. Okay, which is with the vertical. T3 with the vertical. T3 cos theta equals to 50 degree. 50 Newton. Okay, because weight B is 50 Newton. Okay, and then okay, what you can do is you can divide equation 1 with equation 2. Okay, so left hand side equation 1, T3 sin theta, divide with left hand side equation 2, T3 cos theta. So right hand side equation 1 divide with right hand side equation 2. Okay, so you can cancel the T3. Cancel the T3. Okay, sin theta. Okay, I lost my cursor. Okay, sin theta divide with cos theta equals to tangent theta. Tangent theta equals to 28 over 50. Then you can get the theta. Okay, 28 over 50 inverse tangent answer. So it is equals to 29.25 degree. And then you can calculate T3 maybe by using equation 1, or maybe you can use equation 2. Okay, so T3 sin, okay, this is from equation 1. Okay, from equation 1. Okay, T3 sin theta. Theta is 29.25 degree. equals to 28. So T3 equals to 28 over sine 29.25. So it is equals to 57.3 Newton. Okay. So we have two methods here. Okay. Number 5, a 20 kilogram ball is supported from the ceiling by rope A. Okay, rope A. So rope, so that means it has tension. Okay, it has tension. And then rope B. Rope B, that means it has another tension. Pulls downward and to the side on the ball. If the angle of A, okay, rope A, to the vertical is 20 degree. Okay, like this. And if B makes an angle of 50 degree to the vertical as shown in figure, determine the tension in ropes A and ropes B. Okay, maybe we can name tension at rope A as TA and tension at rope B as TB. Okay, so how many objects in this question? Only one. 20 kilogram ball. Okay, so we have only one free body diagram. Okay, so the 20 kilogram ball will have weight, of course, downward, vertically downward. Okay, so for the free body diagram, okay, this ball have weight downward, vertically downward, and then it has TB, okay, because it is pulled by rope B, and then it has TA because it's also pulled by rope A. Okay, this is x-axis and y-axis. Okay, so weight at y component, TA tilted at x and y component, and TB is also tilted. So we have to resolve TA into x component, TAX, and y component, TAY. And also the TB, we can resolve to x component, TBX and TBY, like this. Alright. Okay. So this ball is in equilibrium because that's the keyword here is supported. See? Okay, that means this ball is in equilibrium. It is at rest, doesn't move. Okay. Alright, so we can apply Newton's law. Net force X equals 0 and net force Y equals to 0. Okay, for net force X equals to 0, we have to check at this area. Okay, this is the X component. Okay, so for X component, we have TBX to the right and TAX to the left. So it will be TBX plus negative TAX equals to 0. Alright, so we can relate. Okay, the angle theta is okay, the angle theta is here, 50 degree here, and then 20 degree is at this area. Okay, 20 degree is at this area. 20 degree at this area, so it is equivalent with this one. Okay, this is the alternate angle. Alright, so we can relate TBX with TB and the angle. Okay, so TBX will be TB sine 50 degree, and TAX will be TA sine 20 degree. Okay, equals to 0. So we have two unknown, TB and TA, in this equation. Okay, we leave this equation. We proceed to component component Y. Net force Y equals to 0. Net force Y equals to 0. So for component Y, we have TAY and W and TBY. Okay, we have three forces at component Y: TAY, TBY, and W. Okay, so TAY plus negative W, because it is downward, direction downward, plus negative TBY, negative because it is downward as well. So they are equals to 0. So relate TAY with TA and the angle. So it is TA cos 20 degree, and W is the weight of the ball. Okay, the weight of the ball. Okay, because it's this question give you the mass of the ball, 20 kilogram. So weight equals to mass times G, 9.81. Okay, W equals to mass times acceleration due to gravity. Okay, minus TBY. So relate TBY with TB and angle. So it become TB cos 50 degree. Okay, so equals to 0. Alright, so we have two equation with two unknown. Okay, maybe we can simplify first. Okay, we can simplify. Okay, cos TA cos 20 degree minus TB cos 50 degree equals 20 times 9.81. So it is equals 196.2. Okay, so maybe from equation, okay, we have TA, TB. Okay, maybe we can let TB be the subject from equation 1. So TB equals to TA sine 20 degree over sine 50 degree. So TB equals to sine 20 over sine 50 equals to 0.446 TA. Okay, so maybe we can substitute 1 into equation 2. Okay, so this is mathematics. Okay, you can whatever method, okay, that follow the mathematics rules, okay, to get the answer TA and TB. Okay, as long as you follow the rules of mathematics. Okay, so TA here is, okay, proceed TA cos 20 degree, okay, minus TB. TB is 0.446 TA times cos 50 degree, okay, equals to 196.2. Okay. Now we can get the value of TA. Cos 20, okay, minus in bracket 0.446 times cos 50 degree. Okay, so this equals to 0.65 TA equals to 196.2. So TA equals to 196.2 divided with 0.65. This equals to 300.45. Okay, 300.46 Newton. Okay, and then how about TB? So TB we can calculate from equation 1. Okay, from equation 1, so TB equals to 0.446 times TA, 300.46. So TB equals to 134 Newton. Okay, so you can do whatever that follow mathematics rules. Maybe you can substitute, or maybe you can divide. Okay, anything that follow the rules mathematics. Okay, follow the mathematics rules, as long as you can get the answer TA and TB. Okay. Okay, maybe if you use another method, okay, the answer will be 299.9 Newton for TA. Okay, and maybe for TB you can get the answer is slightly different from the given answer here. Doesn't matter as long the concept is correct. Alright.